All right, law of cosines. Now, law of cosines. Let's go back, review some old stuff from geometry. If you have a triangle, any triangle is called triangle ABC. Remember, the vertices are capital A, B, and C. Points are capital letters. So oftentimes angles are represented by the capital letters. Sides, on the other hand, are represented by lowercase letters. And the side is opposite the angle. So angle A here, side A is opposite of that. So up top here, angle B is up on top, so side B is opposite across of it as B. And then C would be that one, as a little baby C. So here's the law of cosine. There are three formulas for the law of cosines, and I expect you to memorize all three of these. You ready? The first one is a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Give you a chance to catch up on that. The second formula that I expect you to memorize is b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Hey, let's see if you can figure out the third one yourself. The third formula that I expect you to memorize is, hopefully y'all got c squared equals a squared plus b squared minus 2ab times the cosine of angle C. Okay, so here's what's up. Law of cosine. When are we going to use the law of cosine? Well, we're going to use the law of cosine when the triangle information given is, we use this for sassy triangles and sissy triangles. Side, angle, side, and side, side, side. That's when we're going to use the law of cosines. Now, another note that we need to make here are angles are given in degrees, minutes, and seconds, also called DMS. What are you talking about, Smith? Here's the thing. I don't know if you ever noticed this, but you ever looked at a globe or a map or something, and you'll see like the degrees latitude will say like 78 degrees, but then it'll also say 42 minutes, 31 seconds. Or you might have heard it in movies. Come to 78 degrees, 42 minutes. But for some reason, oftentimes degrees, rather than decimals, they use minutes and seconds. All right, and we'll talk more about that as we keep going. So let's get into our first example here. Our first example is draw a triangle, and we'll call this ABC. And I'm going to give you, this is 22, this is 27 degrees, and this is 14. All right, so this is the information that is given. What pattern is this? Last year in geometry, when you were proving triangles, there's patterns that we would do, and one of them was side, angle, side. Right, and that's what pattern this is. This is a side, angle, side triangle because we're given a side. We're given two sides and the angle between those two sides. So it's side, angle, side. So we were given angle B. So which one of the three formulas you think that we should use? Right, we're going to use the B one, the B formula here. So this is going to be B squared equals A. What is A squared here? A squared is 14 squared plus 22 squared minus 2 times 14 times 22 times the cosine of angle B, which in this case is 27. Here's what's nice about this type. Pull out your calculator. And we're going to put this straight in here. We're going to put in 14 squared plus 22 squared. Don't pause, just put the whole thing in. Minus 2 times 14 times 22 times the cosine of 27. A lot of times I see kids, they just put in pieces. And your calculator is pretty outstanding. It can handle this whole thing. Press enter and you get 131 point gross, right? So I'm going to write that. B squared is approximately 131 point gross. 1,4. But here's what's up. We're going to take the square root of that. So we're going to do the square root. Now press second answer. Don't put in the rounded value that I kind of just scribbled down here. Put in the actual answer so we don't round until the very end. Now, since we use a square root to solve, technically the answer is B is plus or minus. But the thing is, can side B here be plus a negative 11.45? No. But here's the thing. We're only going to round to the nearest tenth. Sides, we're going to go to the nearest tenth. So this is going to be 11.5. Right? Great. So now we got B. That's fantastic. But now we got to find the other two angles. Right? So let's work on angle A here. Let's find A. So if we're going to find A, we're going to use the A formula. So this is going to be 14 squared, that's A, equals B squared. Now we just found that B is 11.5. Now, I hate to use rounded values, but in this case, it's okay. We're forced to. We have to. 14 squared is equal to 11.5 squared plus 22 squared minus 2 times 22 times 11.5 times the cosine of angle A. Okay, here's where it gets tricky, and here's where it was nice when we were finding the side we could just put this whole thing in, but this, we can't just put this whole thing in. No. Let's get out our calculator. What is 14 squared? 14 squared is 196, I believe. Yep. So 196 equals, now look here, we've got this thing plus this thing minus, now here's a bunch of multiplication, right? So order of operations says that we have to do the multiplication first. So we'd have to multiply 2, 22, and 11.5. So this is, we have to kind of handle this thing on its own, but then these two things are being added. This is a different group of things going on here, right? So we'd have to multiply these and add these. So pull out your calculator, do 11 and a half squared plus 22 squared. You should get 616.25-ish. All right, minus, put 2 times 22 times 11.5 in your calculator, and you should get 506-ish. 506 times the cosine of A. So we have to break this up into 3 pieces. Right? There's the 14 squared, and then these two things, because multiplying messes us up. Now it's an algebra problem. You're going to subtract 616.25, so 196 minus 616.25. You get negative 420.25. Let's write that down. So 420.25-ish is negative 506 cosine of A. So next thing you're going to do is divide by negative 506. Ew, that's gross. Right? So right now we're at 0.8305 is the cosine of A. That's disgusting. But remember, we're trying to find angle A, so we have to uncosine. How do we uncosine? We inverse cosine. So inverse cosine of the answer. Remember, don't round until we have to. Press enter. Now we get 33.8 degrees. But here's the thing. Like I said back here, angles are going to be given in degrees, minutes, and seconds. So rather than 33.8, I'm going to save you a little bit of time. Press math, and then go to oh, my bad. Not math. Oh, I had a brain fart there. Press second angle. It's the apps button right next to math. And number 4 says DMS. So we're going to take the answer and degrees, minutes, seconds to this bad boy, and we're going to get 33 degrees, 50 minutes, and 47 seconds. Now we are going to round to the nearest minute. Now, since we're rounding to the nearest minute, this is going to be angle A is 33 degrees and 51 minutes. Now, why did I get 51 minutes? This is only 47 seconds. Well, think of a clock. When is more than half of a minute up? After 30 seconds, right? So when we're doing degrees, minutes, seconds, when you look at the seconds, if it's 30 seconds or greater, that's when you round up. If it's less than 30 seconds, you're going to keep it as whatever minute is there right now. So angle A is 33 degrees, 51 minutes. All right, so we still got to find angle C. Right? Well, where are we at now? So far, we have that angle B is 27 degrees. Plus, angle A is 33. Now, here's what's up. You got to press second angle, degrees, 51 minutes, and we're going to be at 60.85. So far, angle B plus this 33 degrees, 51 minutes only adds up to 60 degrees. In a triangle, what is the sum of all three? Be 180, right? So it's going to be 180 minus the sum of these two, which was 60.885. Right? But here's the thing. Just to save us some time, we're going to DMS this as well. DMS our answer. Real quick. If we have 51 minutes right now, how many more minutes do we need? What's the minutes going to be on our third angle? Take a guess. If you guess 9 minutes, you're starting to get this. Anyways, so angle C is 119 degrees, 9 minutes is angle C. All right. Hey, another thing from geometry last year. We found that angle B is 11.5. And we found that angle C is 119 degrees, 9 minutes. First of all, some of you might say, Smith, that doesn't look like 119 degrees. Remember, we drew this before we figured this out. Never trust the picture. That's one thing that we taught you in geometry. Never trust the picture. Another thing that we taught you in geometry is, remember, one of the things that we said was the bigger the side, the bigger the angle. Or vice versa. The bigger the angle, the bigger the side. Which is the smallest angle here? The smallest angle is 27. And its opposite side is 11.5. That happens to be the smallest side as well, right? The medium is 33 with the side that's a little bit bigger than 14, or than 11. 14 is a little bit bigger. The biggest angle has the biggest side. So that kind of makes sense. That's a quick way to do a little quick check. Obviously, it's not a very thorough check, but just to see if you're in the ballpark. So that's for a side angle side. All right, let's do one more example. This last one we're going to do. Draw another triangle. ABC, and it's going to be 9, 12, 13. Hey, what kind of triangle is this? This is a side, side, side. Right, so what's nice about side, side, side is you just know it's going to be a bummer right from the start. That's nice that we just know we just got to get into this. Now, they didn't give us an angle at all here, so we get our choice of what you want to find. So here's the thing. We haven't used the C formula yet. Let's use the C one. So the C formula is side C, 12 squared equals the other two sides, 9 squared plus 13 squared, minus 2 times 9 times 13 times the cosine of C. We have to find angle C. Now remember, this is where it's broken up in the three parts. There's the left side squared. There's the multiplication part, and there's the addition part. So what we got here is 144 equals 9 squared plus 13 squared. What is that? 250. So we got 250 minus 2 times 9 times 13. 234. Oops, my bad. 234 cosine of angle C. All right, so now we got to get angle C by itself. Subtract 250. So 144 minus 250. Negative 106. Divide by negative 234. Divided by negative 234. And you get 0.4530-ish, right? Is the cosine of C. But we're going to inverse cosine, and we're going to do the entire answer. We're not going to put in the rounded value. We're going to put in the original answer, and we get gross 63.06. But this is an angle, right? So now we have to DMS that as well. So second angle, DMS. And we got 63 degrees, 3 minutes, and 51 seconds. So is this going to round up or down? It's going to round up. So this is going to be 63 degrees, 4 minutes is equal to C. All right. Great. So we got C. One of the angles down, 2 more to go. So we got to do this again for one of the other ones. Now, we did C. I'm going to do B this next time. B. So B is going to be B squared, right? The side squared. 9 squared equals 12 squared plus 13 squared minus 2 times 12 times 13 cosine of B. Right? Now, once again, this is the 3 parts. The right side, the addition stuff, and the multiplication stuff. So go ahead and use your calculator real quick. You should get 81 equals. Well, go ahead and do it and check with me once you're done. So hopefully you got to at least 0.7436-ish. It's cosine of B. Inverse cosine of the answer. You should get 41.96. But again, this is an angle, so DMS it. 41 degrees. How many minutes? 58 minutes. Man, everyone's rounding up. 41 degrees, 58 minutes is angle B. So we got two of our angles. We need the third one. So here's what's up. Another way to do this is do 180 minus the 2 that we found, right? That'll give us the third one. But the thing is if you're going to subtract that, make sure you put parentheses, and we're going to add up the 2 that we've got. We have 63 degrees for second angle. Oops, not that one. Second angle. Minutes. That's number 2. That little tick mark is the minutes. Plus 41, again, degrees, not just 58 minutes. And we get 74.96 minutes. So DMS that to get, because this is an angle, and you get 74 degrees, 58 minutes. So angle A is 74 degrees, 58 minutes. So, law of cosines is a lot of fun, as you can see. Bring your questions tomorrow. Smith out!